Hello students, please welcome to the session. In the last class, we have discussed about the chapter electric charges and fields, synopsis, as well as the numerical problems which are given in our classroom discussion. Is it right or not? I hope you all understand those questions, my here. Now let us understand how to solve the questions which are given in the home assignment numerical thing. Okay, I hope ನೀವೆಲ್ಲರೂ solve ಮಾಡಿರ್ತೀವಿ already. ಯಾರಾದ್ರೆ ಸಾಲ್ವ್ ಮಾಡಿರ್ತಿರೋ ಯಾರಾದ್ರೆ ಡೌಟ್ ಬಂದಿರುತ್ತೋ ಅಂತವ್ರು ಈ ವಿಡಿಯೋ ಸೊಲ್ಯೂಷನ್ಸ್ ನೋಡಿ definitely will get a clear picture how can you apply those formulas and how to understand the solving of those numerical problems. Okay, so let us start our class. Let us see the questions one by one. So please go through the first question what they have given to you. An infinitely long thin straight wire has uniform linear charge density. What is the linear charge density they have given? 1 by 3 coulomb per meter they have given. Then the magnitude of the electric intensity at a point 18 centimeter, that is at a distance of 18 centimeter, we have to calculate what is the electric field intensity. Okay, we know that for a straight infinite charge carrying wire, the electric field intensity is given by lambda divided by 2 pi epsilon naught into r. So I will multiply by 4 and divide it by 4. So it will become easy for us here. 4 into lambda divided by 4 pi epsilon naught into r. So just substitute what is the 1 by 4 pi epsilon naught value? 9 into 10 to the power of 9 into what is the lambda they have given? 1 by 3 divided by 18 into 10 to the power of minus 2. 18 10 power minus 2, is it right? 9 1 9 2 2 1 2 2 then it becomes equals to 2 by 3 into 10 to the power of 11. What is the 2 by 3 value here? 0.66 into 10 to the power of 11. Otherwise we can say 6.6 into 10 to the power of 10 Newton per coulomb. 10 Newton per coulomb, is it right? 6.6, otherwise 0.66 in the sense we can select option C as a right answer. I hope you got the answer. Now let us move on to the next question what they have given to you. Please solve this question. Observe this. Electric dipole consists of two opposite charges having the magnitude 1 into 10 to the power of minus 6 coulomb here, separated by a distance. What is the separation between the two charges they have given? 3 centimeter. There is 3 into 10 to the power of minus 2 meter. The dipole is placed in external field. What is the electric field intensity they have given? Electric field intensity is 1 into 10 to the power of 5 Newton per coulomb. What maximum torque does the field exert on the dipole, and how much work must an external agent do turn the dipole end to end? So starting from the position alignment theta is equals to 0. Initially the dipole is along the magnetic field and I want to turn end to end, that is theta 2 must become equals to 180 degree. Okay, let us calculate what is the torque here. Maximum torque is always equals to just P into E, which is nothing but Q into 2A into E. What is the charge they have given? Charge is equals to 1 into 10 to the power of minus 6 into what is the distance between the two charges? 3 centimeter. That is 3 into 10 to the power of minus 2, 1 into 10 to the power of 5. So just multiply here 3 into 10 to the power of minus 8 plus 5, which is nothing but how much you will get here? Minus 8 plus 5, it is nothing but minus 3 Newton meter. We will get it. Torque is equals to 3 into 10 to the power of minus 3 Newton meter. There is only one option, that is option D. Suppose if you want to calculate what is the work done is always equals to, we can say PE into cos theta 1 minus cos theta 2, and they have given clearly that theta 1 is 0 and theta 2 is equals to 180 degree because end to end. Therefore W will become equals to 2 times PE, because cos 180 is minus 1, minus of minus plus 1 in plus 1 will get 2. So 2 into what is the PE value? 3 into 10 to the power of minus 3. It becomes 6 into 10 to the power of minus 3 joules. Is it right? Therefore, we can go with option D as a right answer. Option D as a right answer. I hope you understood this problem. Now, similarly, let us move on to the next question. What they are saying to us. A thin metallic spherical shell contains a charge capital Q. There is a thin metallic spherical shell having a charge capital Q on it. A point charge q, a small charge q is placed at the center of the shell, and another charge q1 is placed outside it. There is another charge q1 here as shown in the figure. All the three charges are positive charges. All the three charges are positive charges. Then the force on the charge at the center is. Since they are asking what is the force on the charge, we know that force F is equals to E into Q. But they are saying at the center, we know that electric field will become equal to 0. Therefore, force will also become equal to 0. Therefore, we can go with option D as a right answer. Option D as a right answer. I hope you got the idea because it is a thin metallic spherical shell. We all studied from the properties that field a charge given to the conductor always resides on the surface, and the field inside the conductor will become equal to 0. Okay, so like that we have to think and we have to analyze the numerical. Now let us move on to the next question. What they are saying to us: an infinite number of point charges, each of charge, what is the charge here, 1 into 10 to the power of minus 6 coulomb, are placed on the x-axis with the coordinates 1, 2, 4, 8 so on up to infinity. If a point charge of 1 coulomb, is kept at the origin, then what is the net force acting on 1 coulomb of charge? Okay, I will draw the diagram first of all. Let us see here. There is x-axis. This is a x-axis, we can say. And how many charges are there here? Charges are placed. See here, capital Q is placed at the origin. And let us see, 1 into 10 to the power of minus 6 is placed distance of 1 meter. And another one, 1 into 10 power minus 6 is placed distance of 2 meter. And another charge, 1 microcoulomb charge is placed at a distance of how much here? 4 meter. Similarly, 1 into 10 power minus 6 is placed at the distance of 8 meter, so on. Then they are asking what is the net force on this capital Q. According to principle of superposition, we can say that net force is always equals to force due to all the charges. Is it right or not? Therefore, F capital Q is equals to K. What is the K value? You can take 1 by 4 pi epsilon naught into 1 into 10 power minus 6 into 1 divided by 1 square plus 1 into 10 power minus 6 into 1 divided by 2 square plus so on up to infinity. So whenever we take 1 into 10 power minus 6 outside here, we know 1 by 4 pi epsilon naught. Okay, 1 by 4 pi epsilon naught as a equal to 10 power 9 10 power 9 into 10 to the power minus 6 into 1 plus 1 by 4 plus 1 by 16 plus 1 by 64 plus so on. How it is? Observe this. We can say 9 into 10 to the power of 3, and whenever we observe this, this is in the form of geometric progression, where first term is equals to 1 and the common ratio is equals to, what is the common ratio? Common ratio is nothing but ratio that is 1 by 4, and 1 by 4 is less than 1 only, therefore sum to infinity. I will write the formula here, A divided by 1 minus R. So whenever we observe this, FQ is equals to 9 into 10 to the power of 3 into 1 divided by 1 minus 1 by 4. So if you do simplification here, you will get it as 4 by 3, 3 1, 3 3. Therefore, force on net charge becomes equals to 3 4 12, 12,000 Newton. We will get it 12,000 Newton. Therefore, we can go with option B as a right answer. I hope you got the idea, So whenever there is geometric progression, we have to think and we have to analyze like this. Sum to infinity, I will write the formula separately if you want. Sum to infinity is always equals to A divided by 1 minus R. Okay. Now similarly, let us move on to the next question. What they have given to you? 4 equal charges small q, each are placed at the 4 corners of a square of side A each. Work done in carrying a charge minus q from its center to infinity is, from its center to its infinity is work done. So please observe that what is the charge I want to move ma, it is equals to minus q, and work done is always equals to, see here, q naught into final potential minus initial potential. Okay, let us call this as equation 1. And we know that potential at infinity is always be taken as 0, always be taken as a 0. Okay, now observe this, what they are saying, there is a square, there is a square, let us name this as a b c d, let o be the center, let o be the center. Therefore what is the potential at the point o, it is always equals to, since all the corners are having the same charge, we can say V due to A, V due to B, V due to C, and V due to what is the D. Therefore, we can write this as directly 4 into 1 by 4 pi epsilon naught into Q divided by OA or OB or OC or OD we can write. So, just simplify, V at the point O is equals to 4 into 10 to the in the options, pi epsilon naught as it is there, let us keep that value as it is. So 1 by 4 pi epsilon naught into q divided by what is OA, OB, OC value here, OA equal to OB equal to OC equal to OD is always equals to root 2 into A by 2, which is nothing but A by root 2, A by root 2. That is the distance between the corner to the center, that is half of the diagonal, half of the diagonal. So we'll just observe this, my 4 will get cancelled here. Therefore potential at the point O becomes equals to root 2 into q divided by root 2 into q divided by pi epsilon naught, pi epsilon naught. Therefore equation 1 implies that w is equals to q naught is the minus q, we can say v infinity is 0 minus root 2 into q divided by pi epsilon naught into a. A is there, therefore substitute and simplify, you will get w is equals to, you can say root 2 into q square divided by pi epsilon naught into a. This is the amount of work done, root 2 into q square divided by pi epsilon naught into a. Hence we can select option D as a right answer, option D as a right answer. I hope you got it, ma. Now let us move on to the next question, what they are saying to us. Please read this question, ma, carefully, what they are saying. Two positive ions, that means let us say q1 equals to q2 is equals to plus q here, carrying a charge small q, they have given already, are separated by a distance d. If F is the force of repulsion between the ions, the number of electrons missing from each ion will be, they are asking how many electrons are missing from each ion. Okay, so how can you simplify this value here? We know that whenever the two charges are separated by some distance d, then there will be a force of attraction or repulsion, and that is given by Coulomb's law. Is it right, ma? Q1 q2 divided by d square, ma. So F becomes equals to 1 by 4 pi epsilon naught into n into E divided by d square. Therefore I want to know what is n here. So n square into E square becomes equals to, we can say, see here, 4 pi epsilon naught F into d square. Is it right, ma? 4 pi epsilon naught F into d square. I want to know what is this n value, ma? N value. Therefore you can say that 4 pi epsilon naught F into d square divided by E square, you will get it under root. Therefore what is the option you will get, ma, here? 4 pi epsilon naught F into d square divided by E in the sense, so we can write this as Q also, ma, here, Q. We can write Q also, no, ma, here. We can say 1 by, E square, you should get it, ma. E square means we can go with option C as the right answer. Is it right or not, ma? Please check it. Root of 1 4 pi epsilon naught F into d square divided by E square. That is, you will get option C. C. Is it clear? I like this. We have to think and we have to do each and every problem. Now let us move on to the next question, what they are saying to us here. So see here, the electric field intensity capital E vector due to an electric dipole of a moment P vector at a point on the equatorial line is, So see here, whenever we consider a dipole like this, I have already explained in the synopsis part only, and whenever we consider a point P on the equatorial line, the net field will be directed as shown in the figure. So dipole moment is always directed from negative charge to positive charge. Therefore, please read the options here. Parallel to the axis of the dipole and opposite to direction of the dipole moment. Is it right? Hence we can go with option A. Perpendicular to the axis ಆಗೋದಿಲ್ಲ, parallel to dipole moment ಆಗಲ್ಲ, perpendicular axis to the dipole ಆಗಲ್ಲ. Is it right or not, ma? So only thing option A. And I have already explained that along the equatorial line, along the equatorial line, the angle between the dipole moment and electric field is always equals to 180 degree. Okay. Now let us see the next question. A charged ball B hangs from a silk thread S, which makes an angle theta with the large charged conducting sheet P as shown in the figure. The surface charge density of the sheet is proportional to, that means they're asking sigma. They're asking how the sigma depends on the theta. So please have a look here, observe this. Whenever we consider a metallic bulb having some charge, the mg will be acting in the downward direction, tension will be acting in the upward direction, and this is theta. This will also become equal to theta. So I can resolve this into two components, t cos theta and the other one is t sin theta. But see here, what happened to this force is equals to E into Q, which is nothing but sigma by 2 epsilon naught into Q. So from the figure we can say that the metallic bulb is in equilibrium condition. Therefore we can say that T into sin theta is equals to E into Q, which is nothing but sigma by 2 epsilon naught into Q. Is it right? And similarly, what is the T cos theta here? We can say it is mg. Let us call the equation 1 and the equation 2. Therefore 1 divided by 2 implies tan theta is equals to sigma into Q divided by 2 epsilon naught into mg. So from this relation we can say that charge density is directly proportional to what? Tan theta. Therefore we can go with option D. I hope you got it clearly. Now please go through it once again, you will get a clear picture here. Now let us move on to the next question, what they are saying to us. So see, they are asking what is the maximum torque and work done in rotating it through 180 degree. Already we have solved a similar problem. I think you can do it here. Charge is equals to 4 into 10 to the power of minus 8 coulomb placed. What is the distance between them? Is equals to 4 into 10 to the power of minus 2 centimeter they have given from a dipole in an external electric field 4 into 10 to the power of 8 Newton per coulomb. So what is the maximum torque here? Maximum torque is always equals to P into E, which is Q into 2A into capital E. What is the Q value here? 4 into 10 power minus 8 into what is the charge? 4 into 10 power minus 4 4 into 10 power minus 4 into what is electric field? 4 into 10 to the power of plus 8 Is it right? Plus 8 minus 8 will get cancelled. 16 for the 64 into 10 to the power of minus 4 Newton meter we will get it. Therefore work done to rotate ಎಲ್ಲಿಂದ ಎಲ್ಲಿಗೆ from theta 1 is equals to 0 degree to theta 2 is equals to 180 degree is equals to 2 times PE. I explained to in the previous problem also. Just go through it once again. Therefore W becomes equals to 2 into 64 into 10 to the power of minus 4. Therefore, you'll get the answer as 128 into 10 to the power of minus 4 joules. We will get it. 128 10 power minus 4 joules. Hence, we can go with there is only one option, that is option A. Option A. There is no other option to confuse you also. So, I think we can do this one. Let us move on to the next question. What they are saying to us. Please observe this. A point charge plus 10 microcoulomb is at a distance of 5 centimeter directly above the center of the square of side 10 centimeter as shown in the figure. What is the magnitude of electric flux through the square? So see here, whenever we consider the magnetic flux, we have to think about what is this here, closed figure. Therefore, we know that flux is always equals to total flux is always equals to, we can say, how many phases will be there for a cube? It is 6 phases are there. 6 into flux, we can say, that is nothing but this is the total flux. Therefore, that is nothing but q by epsilon naught. Is it right? Each phase, therefore flux through each phase is equals to q divided by 6 epsilon naught. In a cube, there will be 6 phases. Therefore, flux through all the 6 phases will become equal to q by epsilon naught. Therefore, we can say, what is the q value they have given? 10 into 10 power minus 6. 10 into 10 to the power of minus 6 divided by 6 into 8.854 into 10 to the power of minus 12. So, whenever we do simplification here, then you will get the answer. As nearly how much you will get here? 1 by 6, in the sense we can say nearly 1.88 something you will get it. 1.88 into 10 to the power of plus 6 will become. So approximately we will get it as 10 to the power of 5 we will get it. That is Newton per coulomb meter square. So what is the option we can say here? 1.88 in the sense we can go with option D. D. So here there are two options which may lead to confusion. Here 1.80 is there and 1.88 is there. So we have to go with the exact calculation up to 2 decimal places. Okay. Now let us see the next question. What they have given to you. A metallic spherical shell has inner radius r1 and outer radius r2. A charge is placed at the center of the spherical cavity. The surface charge density on the inner surface is. They are asking what is the surface charge density on the inner surface. Same type of problem we have solved already in the class discussion also. So observe this. Whenever there is a charge plus q at the center, there will be minus q at the inner surface due to induction and plus q at the outer surface due to induction. But they are asking what is the charge density on the inner surface. Therefore, surface charge density becomes equal to sigma is equals to q divided by area. What is the q on the inner surface? It is minus q. Is it right, minus q divided. What is the area of the inner surface? 4 pi r1 square. Is it right? Because inner radius is r1 or r2. Inner radius is r1 only. So we can go with 4 pi r1 square minus q divided by 4 pi r1 square. Hence we can select option B as a right answer. Minus q divided by 4 pi r1 square. If they ask what is the surface charge density of the outer surface, means then it will become plus q divided by 4 pi r2 square. You will get it. Plus q divided by 4 pi r2 square. So please be careful what they are asking us to calculate. Okay. Now let us move on to the next question. What they are saying to us here. 2 point-like charges q1 and q2 whose strengths are equal in absolute value are placed a certain distance from each other, assuming the field strength to be positive in the positive direction of the x-axis. The signs of the charges q1 and q2 for the graphs. So whenever you observe the graphs carefully, we have to give what is the sign of the two charges Q1 and Q2 for each graph, So one thing we have to keep in our mind, that is E is equals to 1 by 4 pi epsilon naught into plus or minus Q divided by R square. So remember that E is plus or minus proportional to Q divided by R square. That means as the distance increases, electric field will decrease, and as the charge increases, electric field will increase. Charge increase in the sense positive nature, the electric field is positive, and as R decreases, electric field will increase. So based on this, and whenever we go with each and every graph, the suitable option will be option A. So please think about this. Say first graph. In order to have the first graph, Q1 must be positive. And Q2 must be negative. Is it clear? And the second graph, we can say both are positive only. So like that we have to think, and we can answer the given questions here. So please go through it once again. Okay. Now let us move on to the next question. What they are saying here. Please think about this. ಒಂದು ನಿಮಿಷ ನೋಡಿ ಬಿಡೋಣ, ಒಂದ್ಸಲ ನೀಟಾಗಿ ಥಿಂಕ್ ಮಾಡೋಣ. Yes, it is correct only. Please think about this based on this relation. Definitely you'll come to know that. Let's see the next question. What they are saying. Two infinitely parallel metal planes contain electric charges with charge densities plus Q and minus Q respectively, and they are separated by a small distance in air. They are asking what is the magnitude of the field between the two planes with its direction will be. I already explained a similar problem. So whenever we consider two metal sheets, one is having the plus Q and the other one having minus Q. Is it right, So this is a positive charged plate and the negative charged plate. And whenever we think about the point P, field due to positive charge will be in the positive direction towards the negative plate, and field due to negative plate is also towards the negative plate only. Therefore, we can say that the total field will be equals to sigma by 2 epsilon naught plus sigma by 2 epsilon naught, which is equals to sigma by epsilon naught, and it is directed towards the negative plate. Is it clear? Therefore, sigma by epsilon naught towards the negatively charged plane, that is option B, is the right answer. Option B will be the right answer. Okay, got it, Let us see the next question. What they are saying to us clearly. The direction of electric field intensity at a point on the equatorial line of electric dipole already explained, repeat agide, but different way. Along the equatorial line towards the dipole agalla, along the equatorial away from the dipole agalla, perpendicular to the equatorial line and opposite to the dipole moment. Hence we can go with option C as a right answer here. Option C as a right answer. Is it clear? I hope you got it. Because I already explained to you, along the equatorial line, field always be directed opposite to the dipole moment vector. Okay, now let's move on to the next question. What they have given to you, please think about this. Water molecule has electric dipole moment. What is electric dipole moment they have given, 8 into 10 to the power of minus 30 coulomb meter. When it is in vapor state in the sense almost all in the ionic state only, that is hydrogen ions and oxygen ions. The distance in meter between the center of positive and negative charges of the molecule is. So how can we do this problem here? We know that dipole moment is equals to Q into 2A. Okay, therefore we can say that 2A becomes equals to P divided by Q. Therefore 2A, the distance will become equals to, what is the P value? 8 into 10 to the power of minus 30 divided by, what is the Q? Q is nothing but electronic charge only, 1.6 into 10 to the power of minus 19. 8 into 10 power minus 30 divided by 1.6, 1.6. If you do simplification, definitely you will get the answer as nearly 4 into 8 divided by 1.6. If you do no, approximately you will get it as 4. Approximately you will get it as a 4. 4 ಬರುತ್ತಾ ನಿಮ್ಗೆ ಇಲ್ಲಿ? 4 ಬರಲ್ಲ ನಿಮ್ಗೆ. 5 ಬರಬಹುದಾ ನಿಮ್ಗೆ? Yes, we can take approximate is equals to 5. We can say 5 into 10 to the power of minus 30 plus 19, which is nothing but 5 into 10 to the power of we can say minus 11 meter. 5 into 10 power minus 11 meter. Hence we can select option B as a right answer. Option B as a right answer. Is it clear? I hope you are following following each and every step. So let us move on to the next question. What they are saying to us: electric charge uniformly distributed along a long straight wire of radius 1 millimeter. There is a wire and a charge is distributed. A charge is distributed along the line. The charge per unit centimeter, the charge per centimeter of the wire is Q coulomb. That is lambda. Lambda is equals to Q per centimeter. Q per centimeter. Another cylindrical surface of radius 50 centimeter. Another cylindrical surface of radius. What is the radius they have given? 50 centimeter. Radius is equals to 50 centimeter. And what is the length they have given? Length is equals to how much? 1 meter. Length is equals to 1 meter. Symmetrically encloses the wire. The total electric flux passing through cylindrical surface is. So whenever we consider a cylindrical surface and to calculate the flux, we should take only the charge enclosed by that surface. So this surface encloses the wire only of length equal to 1 meter. Therefore, what is the charge enclosed? Enclosed by the cylindrical surface? Let it be Q dash, which is equals to lambda into length, which is nothing. Lambda is how much they have given? Q per centimeter, means Q into 100. So it becomes equals to 100 into Q. This is the total charge. Therefore, flux, they are asking the flux. Flux is equals to Q dash divided by epsilon naught, which is nothing but 100 Q divided by epsilon naught. 100 Q divided by epsilon naught. Hence we can select option B as a right answer. I hope you got the idea on how to simplify or how to analyze such type of numerical problem. These are all the repeated models in various entrance examinations in our India. Okay. Let us see the next question. What they have given to you. What is the electric flux linked with the closed surface? They are asking only closed surface. Okay. So how can you simplify? 1 minute. Please have a look here. You can say that flux is always equals to the total charge divided by epsilon naught. What is the total charge inside the surface? 1.5 plus 7 plus 1 minus 0.4. Minus 0.4 divided by epsilon naught is 8.854 into 10 to the power of minus 12. Okay. So please think and solve this problem. 1.5 plus 7, 8.25, 9.25. 9.25 minus 0.4. It will become approximately 8.8. You will get it. 8.8 something. You will get it. Otherwise 8.85 we can say. Divided by 8.85 into 10 to the power of 12. So it will get 10 to the power of 12. 10 to the power of 12 Newton per coulomb meter square. Hence we can go with option B as a right answer. In order to confuse you, they will be giving the charges outside the surface, but they are asking only the flux through the surface. Okay. So like that we have to analyze the problem. Now let us move on to the next question. What they are saying to us. Please think about this. 3 concentric metallic spherical shells of radius r, 2r and 3r are given the charges q1, q2 and q3 respectively. It is found that surface charge densities on the outer surfaces of the shells are equal. Then the ratio of charge given to the shells q1 is to q2 is to q3 is, they're asking, we have to find out the ratio of the charges, ratio of the charges. First of all, let us draw the diagram. Let us say this is the radius, a shell of radius capital R, and another shell of radius, let it be 2r, and there is another shell of radius 3r. Is it right or not, ma? Radius 3r. So observe this. What is the charge given to you, ma, here? For the first shell, charge is given as a q1. For the shell q2, and the third shell is a q3. Please make sure about this. See, these are all the metal spherical shells. Because of the induction, inner sphere will get minus q, inner surface here q1, and upper surface will get plus q1. And here you can say minus q2 minus q1, and here you will get plus q2 plus q1 you will get. These are total charges we have to concentrate on the outer surface. See, this is the q1 is the total charge on the outer surface of the first sphere. q1 plus q2 is the total charge on the outer surface of the second shell. q1 plus q2 plus q3 be the total charge on the outer surface of the third shell. And they have mentioned that sigma 1 equal to sigma 2 equal to sigma 3. Therefore, how to write sigma 1 here? We can say q1 divided by 4 pi r square, and q2 sigma 2 becomes equals to q2 plus q1 divided by 4 pi into 2r square, and here it is q1 plus q2 plus q3 divided by 4 pi into 3r square. So just simplify, you will get it here. 4 pi will get cancel. R square will also get cancel here. Then what will be remaining with us here? q1 is equals to q1 plus q2 divided by 4 is equals to q1 plus q2 plus q3 divided by 9. So please, from these two things, we can say that q2 becomes equals to 3 times q1, 3 times q1. And observe this, substitute the value from here to here, take these two things. We can say q1 is equals to q1 plus q2 is 3q1 plus q3 divided by 9. So if you do simplification, then q3 becomes equals to 9q1 minus 4 means you get 5q1. Therefore, whenever we take the ratio, observe this, q1 is to q2 is to q3 becomes equals to q1 is to, what is the q2 value, 3q1 is to, what is the value here, 5q1. q1 will get cancel. Therefore, we can write 1 is to 3 is to 5. 1 is to 3 is to 5. So please just go through the calculation once more, then we will get option B as a right answer. I hope you understood this question. Is it right or not? Artha agide alva? So since it is a metal spherical shell, there will be an induction. There will be a process called as induction. Because of the induction process, the charge will be induced in the inner surface and also on the outer surface. Okay. So please go through it. Now let us move on to the next question. What they have given to you. Which of the following is false for the electric field lines of force? Electric field lines of force. Okay. They always start from positive charge and terminate a negative charge. Is correct. They are always perpendicular to surface of a charged conductor. Is also correct. They always forms closed loops. Is wrong. It do not form the closed loop. Loops. Okay. And they're parallel and equally spaced in a region of uniform electric field. So we can go with option C as the right answer. Option C as the right answer. Is it clear? Now let us move on to the next question. 2 point charges 3 meter apart and their combined charge is 8 microcoulomb. The 2 point charges, we don't know that. Q1 is Q and Q2 is equals to capital Q minus Q. Q is equals to 8 minus Q. 8 minus q. The force is repulsion between them is, what is the force of repulsion? 0.012 Newton. Then the charges are, what are the charges? What are the charges? R is also given as 3 meter. R is also given as 3 meter. So how can you simplify this value? See here, we know that force is equals to 1 by 4 pi epsilon naught into q1 q2 divided by r square. So just substitute the value here. 12 into 10 to the power of minus 3 is equals to 1 by 4 pi epsilon naught is 9 into 10 to the power of 9 into, what is the q1? Q1 is q into 8 minus q into 10 to the power of minus 12 divided by r square. R square is 9. R square is 9. So just simplify here. 9 9 will get cancelled here. So left hand side 12 into 10 power minus 3 is equals to q into 8 minus q into 10 to the power of minus 3. 10 power minus 3, 10 power minus 3 will get cancelled. Now simplify here. 12 is equals to 8q minus q square. 8q minus q square. So simplify, q square minus 8q plus 12 will become equal to 0. Simplify here. So how can we get it? Q square minus 6q minus 2q plus 12 will become equal to 0. So whenever we factorize this, q into q minus 6 minus 2, if we take common, q minus 6 will become equal to 0. Therefore, q becomes equals to, what is the value of this? 2, and q2 also become equal to 6. So what is the option we can say here? One is 6 and the other one is 2. Hence we can select option B as a right answer. One is 6 microcoulomb and the other one is, what is that value here? 2 microcoulomb. That is option B as a right answer here. Option B as a right answer. I hope you got the idea. Let us move on to the next question. What they are saying to us. Electron is moving around a hydrogen nucleus in a circular orbit. The force between the two is hydrogen nucleus. They are saying hydrogen means the charge is plus E and here the electron is minus E. So what is the force between them? We know that force is equals to 1 by 4 pi epsilon naught into q1 q2 divided by r square. Is it right? Into r cap, because all the options are in vector representation. Okay, or we can also write this as, see here, 1 by 4 pi epsilon naught into q1 q2 divided by r cube into r vector. So just simplify this value here. F vector is equals to 1 by 4 pi epsilon naught into q1 into q2 ಅಂತಂದ್ರೆ e square divided by r cube into r vector. This is the formula for calculating the force. We should take a negative sign or positive sign here. So see here, negative sign indicates that the electron is bounded to the, what is it here? Electron is bounded to the nucleus. Hence we can go with option A. Minus sign. Why you are taking minus sign? Negative sign indicate that it is a force of attraction. It is a force of attraction. Negative sign indicate it is a force of attraction. Hence we can go with the option A as a right answer. Option A is a right answer. Is it clear? I hope you are all understanding each and every step. Now let us move on to the next question. What they have given to you here. So see here, two charges of magnitude 15 units and 25 units are separated by certain distance here. See here, q1 and q2 both are separated by some distance, let it be d. Now both the charges are brought in contact. After brought in contact, brought in contact, what happens? See here, Q1 dash and Q2 dash are separated by same distance. They are saying here. So what is a Q1 dash is equals to Q2 dash? Then we can say Q1 plus Q2 by 2 will get. So what is the option? Will get 15 plus 25 by 2, which is nothing but 40 by 2, which is nothing but 20 units. 20 units. Therefore, see here, first case F1 will become equals to, F1 will become equal to, or we can say F1, we know that F is directly proportional to product of their charges. Therefore, F1 by F2 directly I will write here. F1 by F2 will become equals to Q1 Q2 divided by Q1 dash into Q2 dash. What is Q1 Q1 Q2 15 into 25. 15 into 25 divided by, we can say 20 into 20. 20 into 20. So please simplify here. So 5 3, 5 4, 5 5, 5 4. You will get the answer as 15 divided by 16. We will get it 15 divided by 16. Hence we can select option D as a right answer. Option D as a right answer. I hope you are understanding. Now similarly, let us move on to the next question. What they are saying to us. See here, the net electric force on a charge of plus 3 microcoulomb at the midpoint of the line join the two charges of magnitude plus 2 microcoulomb and minus 2 microcoulomb separated a distance of 6 millimeter is 6 millimeter is. So how can you simplify this value here? So please, first of all, write the diagram here. There is a plus 2 microcoulomb and there is a minus 2 microcoulomb. Whenever we place a charge of plus 3 microcoulomb at the center, it is 3 millimeter and it also becomes equals to 3 millimeter. Because total distance is 6 mm noma. So whenever we place a charge, Q naught is equals to plus 3 microcoulomb here. Plus 3 microcoulomb here. Observe this. What is the force? Let us say this is the Q1 and this is the Q2. So see here, because this is a positive charge, this is also positive charge, then there will be a force of repulsion. Then there will be a force of repulsion. We can say here. Oh, they are asking what is net force? No, what is the net force? Okay, and this is a minus 2 and this is a plus 2. There is a force of attraction. There is a force of attraction F1 and there is also F2. Therefore, net force becomes equals to, therefore net force will become equals to F1 plus F2. F1 plus F2. So please simplify. Then you will get the idea. Then you will get the idea here. How much we are going to get it here. So whenever we think and whenever we analyze, we can say that 1 by 4 pi epsilon naught into what is Q1? Q1 is 3. Q2 is 2. 3 into 2 into 10 to the power of minus 6 divided by 3 into 3 into 10 to the power of minus 6. We will get it micro 10 power minus 12 here. We will get it 10 power minus 1 more 6 should be there. 1 more 6 should be there here. Minus 6. Okay, plus 3 into 2 only number 2 into 10 to the power of minus 12 divided by 3 into 3 into 10 to the power of minus 6. So just simplify, you will get the answer clearly. You can say that as 2 into 9 into 10 to the power of 9 into, we can say 6 into 10 to the power of minus 12 divided by 9 into 10 to the power of minus 6. We will get it 9 will get cancelled. So 2 into 6 12, 12 into 10 to the power of minus 3 plus 6. We will get it as 12 into 10 to the power of plus 3 Newton here. 12 into 10 power plus 3 Newton. Okay. So how can you get it here? The net electric force on a charge plus 3 microcoulomb at the midpoint of the line joining the two charges. You will get it as what is the answer we are getting here? We can get 12,000 Newton. I am getting 12,000 Newton, 12,000 Newton, but there is no option. But there is no option. Okay, is it right? I think you got the picture how to solve or how to analyze the net force, how to analyze the net force, because they are saying that 3 microcoulomb is placed at midpoint. That means due to positive charge it will be repelled, due to negative charge it will be attracted. It will be attracted. Suppose if they are saying only this is also plus 2 microcoulomb, no, then the net force becomes equal to 0. But anyway, we can go with 12,000 Newton, 12,000 Newton. Hence, we can select, I'll go with the option here. I'll change this option 0. 0 cannot be the answer. Therefore, we can say it should be 12,000 Newton, 12,000 Newton. Hence, we can go with option D as a right answer. Option D as a right answer. I hope you got the picture. You got the picture, and you can easily solve such type of problems. Okay. Now, let us go to the next question. What they are saying to us here. The two charges plus 6 microcoulomb and 15 microcoulomb are placed along the x-axis at x equal to 0 and x equal to 2 meter respectively. A negative charge is placed between such that such a resultant force on it is 0. The negative charge is placed at a distance. They are asking at what distance I want to place a negative charge. I want to place a negative charge. Okay, let us see here. The x equal to 0. What is the charge at this point here? 6 microcoulomb. 6 microcoulomb. And x equal to 2 meter. What is the charge placed here? 15 microcoulomb. And see here. And there is a charge. What is the charge we have placed? Negative charge is placed. We don't know that. Let us say we don't know what is the distance at which it is placed. Let it be x here. And here it will become equals to 2 minus x. 2 minus x. So that the net force must be equal to 0. Why? What is the reason here? So because of this positive charge, the force will be acting like this. And here also the force will be acting like this. Net force equal to 0 implies force due to both the charges on the mid charge, on this minus charge will be same. So just simplify k into what is q1? 6 into q2 is q divided by x square is equals to k into 15 into q divided by 2 minus x whole square. K, q, everything will get cancelled here. So just simplify 6 by 15 is equals to x divided by 2 minus x whole square. We will get it. Now we have to simplify for this in order to get the answer. So see here, x divided by 2 minus x is equal to, what will be the answer here? 3 2s are 2, 3 5, that is 2 by 5 whole power 1 by 2. We will get it. Whole power 1 by 2 we will get it. But whenever we do cross multiplication and simplify, then you may get the answer. Otherwise, you can say 1.4 divided by 2.2 something, you will get it. 2.2 or 2.3 root 5, no? So now do cross multiplication here. 2.3x is equals to 2.8 minus 1.4x. Bring this to left hand side. Then you will get 3.7 into x is equals to 2.8. Or x is equals to 2.8 divided by 3.7. That is 28 divided by 37. 28 divided by 37. What will be the approximate answer? 0.1 something we will get it. Otherwise 0.9. We can go with nearly. Please go through the calculation here. We can say that. Sorry. One nimsha. We can go with 28 by 27. 28 by 27. What will be the answer for this here? If you do exact calculation, I hope you may get the answer as 0.77 something. You will get it. Hence, we can select option A as a right answer. Option A as a right answer. Okay. So like that we have to think and we have to analyze the simplification also. Now let us move on to the next question what they have given to you. Three charges, 1 coulomb, 1 coulomb and 2 microcoulomb are kept at the vertices of A, B and C of an equilateral triangle ABC of side 10 centimeter respectively. The resultant force on the charge at C is, at C is. So see here, let us consider, consider this A and this B and this C. What are the charges we have placed? 1 microcoulomb and this is also 1 microcoulomb. Here it is 2 microcoulomb. And what is the distance as 10 centimeter, 10 centimeter and this is also equals to 10 centimeter. So just observe magnitude at A and at B at C is 1 and 2. Magnitude of charge at B and C is also 1 and 2. That means the force will remain same. No, observe this. This is the force on A and this is the force due to B. Is it clear? Since it is equilateral triangle, then this will also become equals to equilateral triangle. So please calculate that. Let, yes, now in let and beta we know another we know that FA is equals to FB equals to F, which is nothing but 1 by 4 pi epsilon naught into 1 into 2 into 10 to the power of minus 12 divided by 0.1 whole square, 0.1 whole square. Therefore, what is the resultant force here? What is the resultant force? F becomes equals to, we know that F resultant is equals to root of FA square plus FB square plus 2 FA into FB into cos 60, cos 60. So whenever we do simplification here, resultant force will become equals to root 3 times FA or it becomes equals to root 3 times FB. So just substitute all the values, you will get it. Root 3 into, what is FA or FB? 9 into 10 to the power of 9 into, what is this value? 2 into 10 power minus 12 divided by 10 power minus 2. So if you do simplification, you will get 18 root 3 into 10 to the power of minus 3 plus 2. What is 18 root 3 value? Approximately we will get it 18 root 3. 18 into 1.73 into 10 to the power of minus 1. Minus 1. So if you do calculation and simplification, then you will get 1.7. Already I have solved such type of problem here. You will get nearly, 18 2s are 36 something, you will get it now. So approximately here it is 31.2 something, we will get it here. So which is nothing but 3.12 Newton, we can say. 3.12 in the sense we can go with D. How I came to know that? I am not doing exact calculation, just I am having the look at the options and I am going with the approximation, multiplication and division. Okay. So let us see the next question what they are saying to us. See this problem. Two spheres carrying the charges plus 6 and plus 9 microcoulomb here, F proportional to Q1 into Q2, and they are saying distance D, experience a force of repulsion F. Charge of minus 3 microcoulomb is given to both the spheres. Therefore, we can say that Q1 dash become equal to 6 minus 3 microcoulomb. Q2 dash becomes equals to 9 minus 3, that is 6 microcoulomb. Therefore, F2 is proportional to Q1 dash into Q2 dash. Q1 dash into Q2 dash. Okay. Therefore, just go with the approximate calculations here. Then we will get F1 divided by F2 becomes equals to Q1 Q2 divided by Q1 dash into Q2 dash. What is Q1 Q2 value here? 6 into 9 divided by, what is Q1 dash into Q2 dash? 3 into 6. 3 into 6. 6 will get cancelled. 3 1 3 3 here. Therefore, F2 becomes equals to F divided by 3. F divided by 3. Hence we can select option D as a right answer here. Option D as a right answer. Is it clear? So please go through it once again. If any doubt, listen, concentrate on the solution. You will get the idea and you can easily solve here. Now let us move on to the next question. What they are saying to us. Sir. In a region, the intensity electric field is given by intensity electric field E is equals to 13 I cap plus 4 j cap plus k cap ma. And what is the area vector? Area vector is equals to 20 into I cap meter square. Then they're asking what is the electric flux? Electric flux. Therefore, we know that electric flux can be written as the dot product of electric field intensity and the area vector. So whenever we take the dot product here, flux will become equals to 13 I cap plus 4 j cap plus k cap dot 20 into I cap ma. So whenever we multiply this 13 into 20, just a dot product, no, we have to take only the product of respective unit vector coefficients ma. So you'll get 13 into 20, you'll get it. Then you'll get option that is 260. You'll get my 260 Newton per coulomb meter square. You'll get it. So 260 ನಮ್ಗೆ ಇಲ್ವೇ ಇಲ್ಲ, ಮೋಸ್ಟ್ ಪ್ರಾಬಬ್ಲಿ ಇಲ್ಲಿ ಮಿಸ್ ಆಗಿದೆ ನಿಮ್ಗೆ ಇಲ್ಲಿ. ಸೊ ಬೆಟರ್ ಯು ರೈಟ್ ದಿಸ್ ಆಸ್ 260 here 260. Hence we can select option D as a right answer. Option D as a right answer. I hope you got the picture here. ಅರ್ಥ ಆಗಿದೆ ಅಲ್ವಾ ಹೇಗೆ ಮಾಡ್ಬೇಕು ನಾವು ಅಂತಂದ್ಬಿಟ್ಟು. Now let us move on to the next question. What they are saying to us. Please observe this. The electric field at a point due to an electric dipole on an axis inclined at an angle theta less than 90 degree to the dipole axis is perpendicular to the dipole axis if the angle theta is. So what they are saying to us, please see here, there is a dipole minus q and plus q. We know that dipole moment is directed from negative to positive. Let us say this is center. Let us say there is some point P. There is some point P. At this point, let us say this point, that is R, is making an angle theta with the dipole moment. And what they are saying to us, usually we can say this is the resultant electric field. Resultant electric field will make an angle phi with the distance or with the point P. With the point P. So see here, if you resolve this, then it will become E along the, what is that, equatorial, E along the equatorial, and this is the radial one, we can say here is the E radial, we will get it. So whenever we consider this type of things, what is the phi? Phi is the angle made by the resultant electric field with the line, So there is a relation for this, Please note down this here. Tan phi is always be equals to tan theta. Tan phi is always equals to tan theta. Please make a note. But in the problem, they have given that phi plus theta must become equals to 90 degree. Therefore phi becomes equals to 90 minus theta. So just substitute this value here. Then we will get equation 1 anta bariyona illi. Let us call equation 1. Equation 1 implies tan of 90 minus theta is equals to half tan theta. So tan of 90 minus theta will become equal to what here? Tan of 90 minus theta. What is the value we are getting here? Tan 90 minus theta will become equals to, you will get cot theta, no, here. Cot theta, we will get it here. Cot theta is equals to tan theta divided by 2. Is it right? So whenever we take the reciprocal here, what can you write here? ರೆಸಿಪ್ರೋಕಲ್ ನಾವು ತಗೊಂಡಿದ್ದಾಗ ಏನಾಗಬಹುದು ನೋಡಿ ಇಲ್ಲಿ 1 by tan theta is equals to tan theta divided by 2, or we can say tan square theta is equals to 2 ma. Tan square theta is equals to 2, or tan theta will become equals to root 2. Tan theta is equals to root 2. Hence we can select theta is equals to namgilli theta will become equals to tan inverse of root 2. Tan inverse of root 2. Hence we can say option C as the right answer. Option C as the right answer here. I hope you got the clear picture and how to solve all those things. Now similarly, let us move on to the next question. What they are saying to us: electric dipole is placed in a uniform electric field with the dipole axis making an angle theta with the direction of the electric field. The orientation of the dipole for stable equilibrium. So see here, dipole will be stable will be in a stable when potential energy is a minimum. Potential energy of a dipole is equals to minus P cos theta. So when theta is equals to 0 degree, potential energy is minus P, which is said to be minimum. Therefore theta equal to 0 indicate the dipole in stable equilibrium position. Stable equilibrium position. Okay, I hope you understood this question clearly. Now let's move on to the next question. What they are saying to us. So please simplify here. Let's move to the next question. See, observe this. A rod lies along the positive x-axis with one end at the origin and the other at infinity. It carries a uniform charge of charge density lambda coulomb per meter. The electric field at the point x equal to minus a on the axis will be. X equal to minus a on the axis will be. We have to calculate. Actually, you can easily calculate, but anyway, I will give you the hint. Here. So let us say this is a rod. This is a rod having a charge, and it is placed along the x-axis. Is it right or not? This is the x-axis. It is extended up to infinity. And they are asking, what is the field? At the point x equal to minus a. Since this rod is an example of the continuous charge distribution, so let us divide the whole rod into small elements having the length dr and having the charge dq, and which is at a distance of r from the origin. Therefore, what is the field? Due to a small charge dq at the point x equals to minus a, which is nothing but dE will become equals to dE. What is the dq value? You can say dq is always equals to lambda into dr. Charge density into length of that element will give you what is charge of that element. So dE becomes equals to 1 by 4 pi epsilon naught into dq divided by what is the distance here? Distance is r plus a whole square. Therefore, total electric field is always be equals to integration of dE from where to where? From 0 to infinity. Is it right? So just substitute the value of lambda here. dq is lambda into dr, and if you go on integrating this value here, what is dE value? You can say 1 by 4 pi epsilon naught into lambda into dr divided by r plus a whole square. So whenever we integrate from 0 to infinity, then the electric field at the point x equal to minus a will become equals to lambda divided by 4 pi epsilon naught into a minus I cap. Will get it because the field will be directed in the negative x direction. Okay, so we have to integrate. By my suggestion is no need to integrate, and you can remember it as a direct here. So whenever we go with this, then we'll get the option as lambda by 4 pi epsilon naught into a into minus I cap. Hence we can go with option A as a right answer. Option A is the right answer. I hope you got the idea. You got the idea how to analyze and how to solve this problem. Okay. So with this, the problems which are given in the home assignment has been discussed completely. I hope you understood this. So whenever there is a huge tricky, my suggestion, please leave that, because at this moment we cannot go for such problems. Okay, I hope you got it. Please speed up your preparation. We'll meet you in the next chapter. Until then, please keep preparing. Don't waste the time. Okay, thank you very much.